Good morning also from my side. Today I want to give you a brief introduction into two of our concrete modules. The first one will be RF concrete surfaces, and the second one will be RF Punch Pro. So with RF concrete surfaces, you can do the design for the ultimate limit state for surfaces and also for the serviceability limit state. This is the first one. And the second one, as I already mentioned, will be RF Punch Pro. We have launched this module in this summer. It is available since the versions 5.07. And compared to the previous module, it was RF Punch. We are now able to do also the punching proof on wall ends and wall corners. So for this I have already prepared a little file here. You see it already on my screen. This is a really small building just to show you the features in the mentioned modules. At the beginning I want to say some words to the model itself. So I have one bottom slab here and one roof slab. You can see it if you rotate the screen here. The roof slab has a thickness of 30 centimeters, and I will do at first the design of the longitudinal reinforcement for this slab, and after this I will do the punching proof for corners. That will be once here at this point. See it if I rotate the screen. This is once here at the wall corner and on this 3 wall ends. So that is the mentioned new feature in RF Punch Pro. Just some words for the loading. I have used here one load case for the self-weight, and I have applied here 1.5 kilonewton per square meter. And then I have entered 8 load cases for the live load or imposed load cases. And I have applied here a free surface load. With the free surface load I can just tell the program in which coordinates or in which location the load should act. And this load is not connected to a dimension of the surface itself. So if I switch through the single load cases, you see where this load is acting on. Then just some words to the load combination itself. So as Walter already mentioned in the first presentation, in RF Punch Pro you have the possibility to create or automatically create load combinations and result combinations. In the example from Walter, we have used the load combinations. For the concrete design, it is also very common to use the result combinations. I've just opened here the dialog with the general data, and I've also checked on here create combinations automatically. But now I have switched from load combination to result combination. For you, it's important to know that the result combinations are only, or you should only use it for linear analysis. So if you use, for example, nonlinear elements like tension, for example, or releases, nonlinear releases and imperfections, like Walter did in his presentation, then you have to calculate with load combinations. Also, if you calculate with second order analysis, you have to calculate with load combinations. But in this example, it's only for concrete design, and so the linear analysis is quite okay for it. So I activated here these result combinations. If you now take a look here at the list of the result combinations. You see here result combination 7. That was created for the ultimate limit state. Then I have 3 result combinations for the serviceability limit state. It's one's characteristic, then it's frequent and quasi-permanent. And I can use this result combinations 8 till 10 for the serviceability limit state design in RF concrete surfaces. So the calculation of the internal forces is already done in this file, and I can directly open the add-on modules. To open the add-on modules, there are 2 common ways. One is here the menu with add-on modules, and I can go to design and here for concrete, and I can open here RF concrete surfaces. That would be one way. The other way, I think the most common way, is to use the data navigator, and I set RF concrete surfaces and RF Punch Pro as favorites. You see it here in this little folder. If you just do a right click here on the module entries, and you can check it on as a favorite, and it will be listed at the top of the whole list of add-in modules for RFEM 5. So, as I already mentioned, I have prepared 2 cases for RF concrete surfaces, and you can also see it here that the text here is thicker than here for the RF Punch Pro. That means that there is already existing a case in this module. I just open it, and I'm here in case number 1 for the concrete design. In the first mask, general data, or first table general data, you have to set the loading which should be applied for the ultimate limit state and for the serviceability limit state. As I already mentioned, I will use the result combination 7 for the ultimate limit state design, and for the serviceability limit state I have used the result combination 8, 9, and 10. As I mentioned, we have 1 result combination characteristic, 1 frequent, and 1 quasi-permanent. Due to the fact that I have created this, or RFEM has created this combination automatically, this is already correct set to the design values here, to the correct. So that are the basic entries here in the table 1.1. Then I can switch to the materials. In the mask 1.2 you can change the concrete strength class or the reinforcement steel. By default, RF concrete surfaces takes the material from RFEM, so this concrete was already used in the module, and I can leave it as it is. If I want to check another concrete class, and I can change it also here in the module, or in the mask 1.2. The next table is 1.3 surfaces. I have activated in table 1.1 the serviceability limit state design, and therefore I have to do some special settings, or I can set some special values here. At the top list you can see all surfaces which are included in this model. I will just do the design for the upper floor slab, and then I can press here on this filter and tell the program it should just show me the surface which is used here in this module. So it is surface number 1, and in the lower part here I can set, for example, values for the crack width control or minimum reinforcement and so on. So that is for the serviceability limit state. Then the next table is for the reinforcement itself. So RF concrete surfaces is working with reinforcement groups. By default, it creates one reinforcement group in which all surfaces of the module are included. In my case, I have only applied here the surface number 1. It's the roof slab. And for this roof slab, I will do the design. I can switch directly here to the mask with the longitudinal reinforcement. And here you can check out the basic reinforcement, which I've already entered here. So you see here the values for the top level in both directions, the bottom level, and also the diameters, which I've tried to use for the design. And also here in the lower part, you see additional reinforcement. So if this provided reinforcement, which I've entered, doesn't fit or is too less, you can also tell the program it should add automatically additional required reinforcement. And if there is an additional reinforcement required, then I will also use the same diameter, so 14 millimeters in this case. If you want to change some parameters for the national annex, you can go to this mask here and check the values which are here pre-selected. If you want to do some modifications for the code, then you can do it in this table here. So that are the basic entries I have to do now, or I have already done, and I can just click here on calculation. It just takes some moments to do the design here. So after this, I've got two result masks. One is the required reinforcement here, and one is the result mask for the serviceability design. So that is due to ultimate limit state here, and that is that are the design ratios for the serviceability design. I want to show you just shortly the results here in the graphics. I press on the button with the graphics here, and you see here which reinforcement was selected from the module for the serviceability limit state. So this is the value which I've entered as provided basic reinforcement, and I can switch here through the levels. It is the top level in direction 1, top level in direction 2, then the bottom level. And so you see here there are no additional reinforcement required, but in this, on the top level in the direction 1, you see we have a basic reinforcement of 10.26 square centimeters per meter. That was the value which I entered, and on some points we need additional reinforcement. So that is this one here, which you see here. You can now say as a customer, please, it should be arranged automatically, this additional reinforcement, like it was done in this case. If I click here on this required additional reinforcement, then I say in which locations I need additional reinforcement, which should be added to the provided basic reinforcement. That is one option. A further option in RF concrete surfaces is that you define the provided reinforcement completely by your own before you start the design. I have entered for this second case in RF concrete surfaces, so I switch here to case 2, manually defined reinforcement. And if I click now here on the table 1.4 with reinforcement, and if I change to the longitudinal reinforcement, then the mask here has changed. So I can just switch between the two cases to show it to you. In this case, you just define which diameters should be used here for the additional reinforcement, and the program determines automatically the amount of the additional reinforcement. If I switch to the case 2, this mask has changed and I have to set the provided additional reinforcement by my own. Now that gives you the possibility to define it on every point of the slab a certain amount of reinforcement. To get this mask here, you have to go to the details, and on the register here reinforcement, and then switch from automatic arrangement, that was the case 1, to manual definition of the reinforcement. That is the second option here. I have done it in this example already. I have prepared it already, and now I will show you which reinforcement is already entered here. If I just click here on this edit button, then you see here a list of reinforcement, and this is the additional reinforcement which was added by me. So I can click here on this eye to show you this additional reinforcement. And now I am here on provided additional reinforcement, and you see this area in which I said I will use additional reinforcement which was completely defined by my own. So I can switch through this. That is the top side. I can also switch here to the bottom side. And with this provided total reinforcement, I will now do the calculation for the ultimate limit state and serviceability limit state design. So I click here once with OK. Click on calculation. Takes a little bit longer to calculate serviceability. Also, if you just do the ultimate limit state, then it's faster, the calculation. So we go now to the results on the serviceability design, and you see here the design ratios of the total slab. Every design is fulfilled, so I can go to the graphics. And you can click here on not covered reinforcement to check whether your added or your defined reinforcement is enough, or whether you have to rise up the value in the module. So I can click here on not covered reinforcement and switch through the directions here. On the top side, in direction 1, it's okay, so the defined reinforcement is enough in this location. Then I switch to the bottom side. There is one little value, but I think it is okay in this example here. And on the bottom side, there is everything covered, so the defined reinforcement is okay, and the design is fulfilled. You can also click here in the result navigator on the serviceability limit state design ratios, for example, for the stresses in the steel. You see it here. Then the minimum concrete here, minimum reinforcement, and you see here the design ratios for these verifications. What I've shown you now was the way or the basics for RF Punch Pro, because I want to know the total provided reinforcement here in the top directions, and I will now apply this reinforcement or use this reinforcement in the new module RF Punch Pro. So to start RF Punch Pro, I switch to the data navigator and just do a double click on the module entry, and RF Punch Pro opens here in the table 1.1 with case 1. That's okay. And now I can select here or pick here the nodes which should be used for the punching proof. So I switch off the results from concrete surfaces to see just the model, and I can switch also to the wireframe display model. And once I selected here this one, this node, and this node. So I will do now the punching proof on the wall corner and on this 3 wall ends. I click here on OK, and then I have to select loading for the punching proof, and in this case it is the result combination 7. The annex for the Eurocode is already correct in this example. If you want to choose another annex, then you have here the whole list of annexes which are implemented at the moment in RF Punch Pro. So I switch to the next table. It is 1.2, and this is quite similar to RF concrete surfaces. The module knows the topology of the RFEM model. So the concrete class is already preset here, and also the thickness of the 30 centimeter is already entered in this table. If you want to change it here in the model just for testing of other thicknesses, you can enter this value directly here. Then to the next mask, it is the 1.3 additional openings, and in the table additional openings you can enter openings which are not considered in the RFEM model itself. So if I just close this once again, I have here this roof slab. Go to the views navigator and just activate it once again. So it looks like this. So it looks like this, and in this slab I have already entered one opening. So this opening is considered in the model itself and also is considered by the determination of the internal forces. If you have smaller openings which are not considered in the model itself, but you have to, or you want to consider it for the punching proof, then you have to enter them in this mentioned mask 1.3. So openings which are already in model are considered automatically by the module. Openings which are not considered in the model have to be entered here in this table 1.3 additional openings. I can give you just a quick example. So I go here to the mask 1. I set the reference node, for example this one here. Then I can enter the location and the dimension of this opening. So, and now you see this additional opening. So this opening is not considered in RFEM. In RFEM we have just this big opening, for example for a stairway or something like this. And this opening will be considered in the punching proof. So in this example I will delete it again. And I go to the next table. It's 1.4 with the longitudinal reinforcement. In this table you don't have to enter the exact amount of reinforcement. You just have to set the correct concrete covering. So we have used at first in concrete surfaces the diameter of 14 millimeters. So I can here modify this value to 4.4. And you see here how this thickness of this longitudinal reinforcement is changing. Just if you show, take a look at the graphics here. If you increase it, it rises here. And now I will consider this 3 centimeter in direction 1 and 4.4 in direction 2. The amount of provided longitudinal reinforcement can be set in the table 1.4. So I switch 1.5. So I switch to the table 1.5, and there you can set all settings for each punching point. You see here in this upper part the four nodes. One is the 5, 6, 8, and 9. And what's new in RF Punch Pro compared to the old RF Punch is that the program now automatically knows which punching shape it is. So in this point number 5, it is a wall corner. So the module knows exactly how the punching shape should look like, and it is automatically defined here in this example. Also for the wall ends here, you see it here, and in point number 9. So I will now do the design on these 4 nodes with the calculated longitudinal reinforcement from RF concrete surfaces, and I will check whether this longitudinal reinforcement is enough to avoid vertical shear reinforcement. So I said here in this column C that I want to use vertical reinforcement if the longitudinal reinforcement is not enough. So I leave it as it is, and I just go here to node number 5, for example, and switch here in this bottom part here into the longitudinal reinforcement and cross-section, and I check define here on, and then I can enter here these values for the node number 5. It was 12.32 and 15.39, and then I do it for the others in the same way. So I have entered now exactly the same reinforcement which I have entered in RF concrete surfaces here in RF Punch Pro on these nodes, and now I will start the calculation and check whether this provided longitudinal reinforcement is enough to avoid vertical shear punch reinforcement. So I can directly start the calculation here. And you see here now in table 2.1 the results and design criteria for all 4 nodes. In node 5, 6, and 9, you see here the design criterion is lower than 1. So with this provided longitudinal reinforcement, we don't need an additional punching reinforcement. On this point 8, is this point here, you see the shear resistance due to this defined longitudinal reinforcement is too small. So in this point we need an additional punching reinforcement. This is already, or the additional punching reinforcement will be determined automatically by the module. So we can click here on the next table, it's 2.2. And you see all the values which I've entered. This is the longitudinal reinforcement in the top layer here. And here on point 8, where I need additional reinforcement, you see these two parameters, design parameters, and on these two parameters, if you scroll here in, I would need that amount of additional reinforcement or of punching reinforcement to fulfill the design. So as customer has now the option to increase the amount of longitudinal reinforcement. That would be one solution. So we could go back into table 1.5 and increase this amount here. Or you can accept these results and you can use this punching reinforcement here. So the design here is done and I can switch directly to the graphics, and you can show this design here on the ISO bands, for example. And if you go to this result navigator, you can now click on the design ratios. So you see here design ratio for the punching proof in the critical parameter. It's on 1. I just change again to ISO lines. You see the values here. So on these points here, it is fulfilled with 0.85, 87, 89, and on this point, the design ratio is not fulfilled with 1.06, and I need an additional shear reinforcement here in this point, so I can switch here in the result navigator, and the program tells me how I should arrange this additional shear reinforcement on this wall end. So that's basically the whole thing of designing or punching proof on wall ends. One additional option we also have in RF Punch Pro is to add column head enlargements. That is also a new feature. I have just not prepared it in this case. Yeah. I will just give you a short advice where you can find it in the module. So if you open the module once again, create a new case, you can select a column, for example this one here. Select again a loading, and if I switch now to the mask 1.5, then you see here this node with this column on the edge of the plate. The module has already detected that it's a column on the edge, and if you like to avoid punching reinforcement, then we have now this option for column head enlargement. So it would be here in this case, and you can activate here a column head enlargement. That's all just as info for you. I switch just once again to the case 1. For the results of RF Punch Pro, we have also the option, as it Walter already shown in this presentation, to use the serial print. So if you want to print these results into the printout report, just click here on this button for the printer, and you can use here this mass print. And in this mass print, we have also the results for the punching proof. I can just give you a quick demo. For example, I'll show this one here, and the longitudinal reinforcement. Okay, so I have 9 graphics. Okay. That's it. That's okay. 50%. There's a window. Okay. And now you can see all 9 graphics here in the printout report. And if you want to modify it, for example, the reinforcement, the shear reinforcement, then you can just click here, edit, zoom in, for example, in this way, or go to Z direction this way, for example. Click on back. And now you have modified this picture in a fast way. So, I'm finished, I think. Thanks for your attention. I hope it was informative for you.